Just a short video to finish up histology, and really what this part is about is just how do I connect histology, which a lot of students have trouble understanding and picturing how it fits into the anatomy that you can see with the naked eye. How do I fit that together with the gross anatomy that I'm going to be covering for the rest of the semester? So in most of the rest of the semester, we are going to be covering like anatomy that's visible with the naked eye, like organs and organ systems. But I'll always come back and revisit histology, whether you want me to or not. For instance, when we get to the cardiovascular system, I will revisit what cardiac muscle looks like and why those intercalated discs matter and those kinds of things. But for right now, I'm going to try to connect from histology out to organs and organ systems. So with this, I want to talk about basically if you look at any organ, any hollow organ, for instance, what could you predict about the histology of that hollow organ? And then what would the specialization of that hollow organ tell you about the organ's function? Sort of this structure-function connection, but trying to connect histology to gross anatomy. So you see in your notes, there's this just diagram of a hollow organ, and it's not even telling you which one it is. And here's another figure with a diagram of a hollow organ, and this one's actually from the colon. So if you look at a hollow organ, what do you see, and what does it tell you about what you see? Well, on the inner surface, almost invariably in a hollow organ, you're going to find epithelial tissue, because you know epithelial tissue lines things. And what do you expect to find just deep to the epithelial tissue? Just below the basement membrane? Well, you're going to find some connective tissue, because that's what goes there, right? The epithelial tissue on the inner surface, depending on whether it's thin or thick, it might tell you something about maybe this tissue is either protective or doing transport. If it's got goblet cells, maybe it's telling you that it needs a mucus secretion. If it has cilia, it's moving something across the surface. So there's a lot of information that can be gleaned from what tissue you see there. And then you're always going to have a basement membrane underneath, whether you can see it or not. It should be right about there. Basement membrane, remember, is not a tissue, but it's going to be between epithelial tissue and the connective tissue beneath it. Then, of course, you're going to have this connective tissue. And the connective tissue is sometimes going to have a layer of muscle behind it. The connective tissue could be dense irregular or loose irregular, depending on how strong the organ needs to be, and that tells you something about the organ as well. And then you may have a thin or a thick muscular layer, and if it's thin, maybe it's moving liquids, and if it's thick, maybe it's moving solids. And that can be thin or thick. And then on the outside, you will either have a serous membrane. For instance, if it's in the ventral body cavity, you're going to have a serous membrane. Or it could, that's called a serosa, serous membrane or serosa. Or the organ could be stuck to another organ, and then instead of having a serous membrane on the surface, it would have connective tissue on the surface, and that's called Adventitia. So what's on the outside of the organ, that can sort of tell you about it. So we've got this one here, and this one here is showing you, for instance, like some kind of columnar epithelium. That one's probably more likely to be for transport than this one that's showing you like a stratified squamous epithelium. And here's an actual histology slide, cross-section of a portion of the gut, showing you epithelial tissue and then connective tissue, and then this is muscular tissue, and then you're going to have serosa or adventitia on the outside. Okay, so now let's talk about the very, very simplest organs. Since an organ, it's really just two tissues functioning together. The very simplest organs don't even have to look like a typical organ. They are actually called body membranes. And it's really a combination of an epithelial tissue and then the connective tissue underneath it. And that alone makes it an organ. Of course, there's going to be a basement membrane in there, but remember, basement membranes, not tissues. Basically just sticky stuff that are sticking the tissues together. So two tissues that combine and function together to do a job are an organ. So what are the simplest organs? the simplest organs are like, this is actually an organ. This portion plus the connective tissue underneath it, that is actually called a mucous membrane or a mucosa. So the epithelial tissue plus the connective tissue underneath it, if it has a source of moisture and it's got an epithelial and a connective tissue underneath it, like in the digestive, the respiratory, and the urogenital tract, it's quite often called a mucous membrane, generally speaking, because there's mucus secretions in it. And whether the superficial epithelial tissue is thin or thick has to do with whether it's a site that's doing transport. Like, for instance, the mucous membrane lining my mouth doesn't do transport into the bloodstream. That's just about mechanical digestion, not absorption. So this is going to have a thick epithelial tissue like this. But by the time you get down to the intestine, small or large intestine, it's going to have a thin epithelium, and it's actually going to do transport. So the superficial epithelial tissue on a mucous membrane is either some kind of moist stratified squamous epithelium or usually some kind of columnar epithelium. Maybe simple columnar, maybe pseudostratified columnar in the respiratory tract. And then, of course, you're going to have underneath that is going to be a connective tissue. The connective tissue that's usually right under that is loose areolar connective tissue. And this layer is called the mucosa, or mucous membrane. And then we've already learned about serous membranes, but you wouldn't think of them as an organ unless I told you that they're an organ. They are an organ. So your liver is an organ that actually has an organ on top called your serous membrane, right? Serous membrane doesn't sound like an organ, but it's two tissues functioning together, so it technically is. So, for instance, here is the small intestine. Here's the serous membrane. Serous membrane is composed of 2 layers of tissue as well. It is going to have simple squamous epithelium, basement membrane, which is not a tissue, and then loose areolar connective tissue underneath it, and that makes it an organ. So this is an organ sitting on top of this organ. And of course, you already learned that the serous membrane in the entire abdominopelvic cavity is called the peritoneum. The serous membrane up in the thoracic cavity, pleura pericardium. Okay, and then the last one is just a cutaneous membrane, which is the name for the skin. And the skin, we'll do a whole chapter on it, but we're going to do it a little later because it's not that hard for you guys, and I like to stay with you when you're doing bone and muscle, which is kind of difficult. Okay, so cutaneous membrane is an organ. It's actually the biggest organ in your body, and it's composed of 2+ layers of tissue. The top layer you already know, right, from here to here, is keratinized stratified squamous epithelium. And then there's actually 2 layers of connective tissue underneath it. A complex, this portion called the papillary layer of the dermis is primarily made of loose areolar connective tissue. And then this one down here, can you tell what that tissue is? Because it's a pretty good slide of it. The reticular layer of the dermis, that's made of, what do you think? That's dense, irregular connective tissue. But regardless, this makes it an organ. So the skin is the biggest organ in your body. And that is it for histology. I want to point out to you one more time, this little rabbit hole, a couple of different places that you can look at: digital histology, TGC histology page, histology guide. Those are all practice places that you could go for practicing histology.